This is the second video on section P2. We'll be finishing up with simplifying radical expressions. First is an example of a radical that we've been simplifying probably since Algebra 1 geometry. We're going to rewrite the square root of 72 so that we can see a perfect square factor in there. So we can rewrite it as 2 times 36. And because 36 is a perfect square, we're going to be able to take out a square root for it and rewrite this as 6 square root of 2. Alright, the second one's a cube root. This means we have to have a perfect cube or a number with 3 of the same factors in order to take out of the radical. We also have a negative. So we're going to start this by breaking down negative 250 into a negative 5, and that would give us times 50. Alright, now I'm going to be able to rewrite that as a negative 5 times another negative 5 times a negative 10. Alright, now I've got 3 negatives multiplying. I've got a negative under the radical, and then finally I can look at this and I can rewrite it as a negative 5 times a negative 5 times a negative 5 times a 2. So basically 125 is a perfect square, and I'm going to be able to take out a negative 5 as one of the 3 factors that I can take out for the cube root. So a negative 5 comes out, and I leave the cube root of 2 inside. Notice that if I'm taking the cube root of a negative here, that my answer has to be taking out a negative. If I'm taking a square root over here, I cannot be taking the square root of a negative. Alright, now we've got a cube root and we've got some powers in there. So again, I need to have 3 of the same factors in order to take something out. So I'm going to rewrite this, and I'm going to rewrite the 54 as 2 times 27. Alright, and 27 is going to be able to be written as 3 factors. So that means I'm going to be able to take out for that cube root. Now the powers, I think of those as each of those as many as I can of the third powers of either x to the 6th or y to the 10th. So for the x to the 6th, I can rewrite that as x to the 3rd times x to the 3rd. And for y to the 10th, I can write that as y to the 3rd times y to the 3rd times y to the 3rd times y. And now we're taking out for the 2 factors of x cubes, and we're taking out for the 3 factors of y to the 3rd. So we've got a 3 outside, an x to the 2nd power, a y to the 3rd power. What's left inside are our factor of 2 and our factor of y. And those stay inside cube root of 2y. Alright, now for adding and subtracting, we cannot add or subtract unless we've got like radicals. We don't have like radicals inside the radicals here, but we can simplify both of those, and that's where we go to with it. Right? Take the 3 root 12 and rewrite that as 3 times 4 times 3. Got a perfect square in the 4, so we're going to be able to take out the 2. It's going to multiply the 3 that's already out there. Right? We rewrite the 75 as 3 times 25. Got a perfect cube there. So the 2 that's already out there, we take out the 5, and the square root of 3 remains. And now we have 6 root 3, take away 10 root 3, and we do have like radicals, so we're able to combine the two radicals by the outside parts. You can think about those as coefficients, and rewrite our answer as negative 4 root 3. Now we've got the next problem that's got cube roots and variables again. So we're going to break that down. Look as negative 2x times the cube root of 8 times 5. Got a perfect cube in the 8. And the x to the 5th, we're going to break that down as x to the 3rd times x squared. So we're going to be able to take off for the x to the 3rd. And so rewriting this expression now, the minus 2x is already outside of the cube root. We're taking out a 2 for the 8. We're taking out an x for the x to the 3rd. And remaining inside the cube root, we've got 5x squared. And our first expression can rewrite as minus 4x squared times the cube root of 5x squared. Now, we come over and we finish with the second expression, and we've got 5 and the cube root. Divide the 135 by 5, and there's 27, so we've got a perfect cube there. And the powers of 8 we break down as x to the 3rd times x to the 3rd times x squared. And now we'll be able to have the 5 outside that radical, taking out the 3 for the 27, and taking out an x squared for each one of the x to the 3rd powers. And that would leave inside of our cube root the 5x squared. And we'll be able to rewrite that second expression as 15x squared times the cube root of 5x squared. And finally, we can see that we do have like radical expressions. So the parts on the outside, which also happen to be like terms, are going to be able to combine. So we can come back and write our answer as a positive 11x squared times the cube root of 5x squared. Now, continuing on, we've got multiply some expressions in terms of two radical expressions. So here we're going to apply like we would multiply polynomials, and we have square root of 6 times square root of 6 here, and that's going to give us square root of 36. And as we multiply here, we're going to have plus 3 square root of 6. Now we're multiplying through by the negative 5. Negative 5 square root of 6, and finally a minus 15. This is a perfect square. We've got 6. Here we've got like radical terms. That's a minus 2 square root of 6, and the minus 15 we can put back together with the 6, and we end up with a negative 9. Take away 2 square root of 6. Do not put the negative 9 and the negative 2 together. The negative 2 is part of the radical term and cannot be combined with the negative 9. Alright, a little bit more complicated expression here. We're still multiplying first term times first term. This would be a 9 times square root of 4. Here we have a positive 15, radical 2. Multiplying through the inside, we have a minus 15 radical 2. And then last term times last term, we have a minus 25. The radical terms are opposite, and they eliminate each other. 9 times square root of 4 is going to be the same as 9 times 2, and that's 18. Take away 25, we end up with a negative 7. Now we're going to finish up with a couple more calculations involving radical expressions. This next problem is going to have a square binomial, so we're going to be multiplying radical x minus 4 times itself. And as we multiply radical times radical, we'll have radical x squared. Outside products, a minus 4 radical x. And now we multiply negative 4 times radical x. And finally negative 4 times negative 4. We have square root of x squared is x. Two like radical terms combine to negative 8 radical x. And the 16. And with no like terms, we are finished. Now the next problem is also going to square a binomial expression. And the first term is the radical term, and the plus 3 is the second term. So as we multiply this by itself, it's going to be radical x minus 2 plus 3 times radical x plus 2. Oops, excuse me. That's going to be a minus 2. And a plus 3. And now we're going to continue multiplying. Alright, now we're going to take first term times first term. So we have a radical times a radical, and that's going to give us radical of the quantity x minus 2 squared, which means it's going to remove the radical. And outside we're going to have plus 3, radical x minus 2, and now we'll have another plus 3, radical x minus 2, and then finally a plus 9. So here the radical undoes the squaring, and that means we will just have an x minus 2 quantity come out. The two like radicals combine as 6, radical x minus 2. And then of course we have the plus 9, which then lets us combine like terms. And we can write our expression as x plus 6, radical x minus 2, and then plus 7. And you've got nothing else left you can do there. Now the last thing we have is some rationalizing, and we've got two types of expressions to do that with. The first one, we can look at this radical as square root of 7 over square root of 40, and we can break down the square root of 40 to simplify that radical. We're going to be able to take a 2 out. So we have a radical 7 over 2 radical 10. Now the next thing that we do is called rationalizing the denominator. We're not going to leave any answers that are in exact form with a radical in there. So we go to a technique that we learned in geometry in last year, and we're going to get rid of the radical that's down here by multiplying top and bottom by the same radical. That way we're multiplying the fraction by 1. We're not changing the value of the fraction. Right? The numerator becomes square root of 70. The denominator becomes 2 times the square root of 100, which is 10. And then we can write our final answer as square root of 70 over 20. And now your radical is simplified as well as your denominator being rationalized. All right, last problem. This time there's an expression in the denominator, but there's two terms in there. So if you can think back a couple problems, when we multiplied a two-term expression by another two-term expression with just a different sign in between, we actually got rid of all the radicals. So that's the strategy that we use here. We call it a conjugate. We take that binomial expression and we simply change the sign in between of it. Root 5 plus 2. And then just like the other problem with the rationalizing, so we're not changing the value of the fraction, we multiply top and bottom by the same thing so that we're really multiplying by 1. The strategy is that this bottom multiplication is going to multiply and clear out all the different radicals that are there and let us have a rationalized answer. So now we go back and we go through with the multiplication. So in the numerator, we're multiplying the 2 times the root 5, 2 root 5, and we multiply the 2 times the plus 2, and we have a plus 4. In the denominator, the magic should happen. Radical 5 times radical 5, radical 25. Here we have radical 5 times a positive 2, 2 radical 5. And here's a negative 2 times a radical 5. There's the magic. And finally, last multiplication, negative 2 times positive 2 is a negative 4. So we've got some simplifying. The radicals are knocking each other out here, and we've got a perfect square down here. So we are able to rewrite the denominator with no radical expression at all. Numerator has to be left as 2 radical 5 plus 4, and the denominator we're left with 5 minus 4, which lets us finally just rewrite the answer as 2 radical 5 plus 4 over 1, or just 2 radical 5 plus 4. All right, so now you should be ready for day 3 on your homework tomorrow, and we'll see you there and see if you need any help. This is the second video for section P2